Alan Turing is a name synonymous with the foundations of computer science and artificial intelligence. His ideas and inventions not only helped defeat tyranny during World War II, but also laid the groundwork for modern computing. Turing's legacy is profound, influencing various fields from cryptography to AI, and his contributions continue to resonate in technology today. Born in 1912, Turing was a visionary mathematician and logician whose work has shaped the very way we interact with technology. His intellectual pursuits at Cambridge and Princeton set the stage for a series of breakthroughs that would redefine the scientific landscape of the 20th century. Turing's story is not just about technology, but about a brilliant mind's journey through challenges and achievements. As we delve deeper into Turing's life and work, we uncover the origins of his most famous contribution, the Turing test. This test, simple yet profound, challenges our understanding of intelligence and sets a benchmark that still stirs debate among technologists and philosophers alike. As we explore this and more, we understand why Turing's impact is not just historical, but deeply relevant today. Alan Turing's journey into the realms of mathematics and logic began at an early age. He displayed an extraordinary aptitude for numbers and puzzles, setting him apart from his peers. His education at Sherborne School and later at King's College, Cambridge, honed his prodigious talents, leading him to groundbreaking work in mathematical logic. During his time at Cambridge, Turing was profoundly influenced by the work of mathematicians such as Kurt Gödel and Bertrand Russell. Their work on formal logic and paradoxes fed into Turing's own thinking about the limitations and capabilities of machines. It was here that Turing began formulating his ideas about computational processes and their potential to mimic human reasoning. Turing's academic brilliance earned him a fellowship at King's College by the age of 22, a testament to his innovative thinking and problem-solving skills. His early work laid the foundational theories for what would later become digital computing. Turing's thesis provided a formalization and extension of the algorithmic theory, which became a cornerstone for all future computer science. At the outbreak of World War II, Turing's skills were turned to a critical task, breaking the Enigma code used by Nazi Germany. His role at Bletchley Park, Britain's code-breaking center, was pivotal. Here, Turing's innovations would turn the tide of war in the Allies' favor, showcasing his genius in practical problem-solving. Turing developed the Bomba machine, an electromechanical device that significantly enhanced the ability to decipher German communications. This breakthrough not only saved countless lives, but also shortened the war in Europe by an estimated 2 years. Turing's work during this period demonstrated his extraordinary ability to apply abstract concepts to real-world problems. Despite the monumental success of his wartime efforts, much of Turing's work remained classified for decades after the war, obscuring the full extent of his contributions during his lifetime. It was only in later years that the critical role he played in the war effort and in the development of modern computing was fully recognized and appreciated. In 1950, Turing published a seminal paper titled Computing Machinery and Intelligence, which posed the question, can machines think? This paper not only challenged the very definition of thinking, but also proposed an experiment to test machine intelligence, now known as the Turing test. The Turing test involves a human judge engaging in a natural language conversation with both a human and a machine, which are hidden from view. If the judge cannot reliably tell the machine from the human is considered to have demonstrated human-like intelligence. This simple test has profound implications, questioning the nature of thought and the potential of machines. Turing's test was groundbreaking because it offered a measurable criterion for intelligence that was independent of the machine's ability to mimic human appearance or emotions. It shifted the focus from the form to the function of intelligence, sparking debates that continue in philosophical and technical circles about what it means to be intelligent. Section 5. The conditions of the Turing test. The Turing test sets specific conditions to assess the intelligence of a machine. The test's beauty lies in its simplicity and its challenge. It does not require the machine to possess knowledge or consciousness. Rather, it must be capable of sustaining a conversation indistinguishable from that of a human. This test is conducted through a text-only channel to avoid nonverbal cues and focuses on the machine's ability to generate human-like responses. The criteria are stringent. The machine must not only answer questions but also initiate conversation, display humor, and exhibit self-correction. all while maintaining a coherent and contextually appropriate dialogue. Critics of the Turing test argue that it measures only one aspect of intelligence, linguistic ability, and not the full spectrum of cognitive abilities. Nonetheless, the test remains a valuable tool in AI research, providing a clear goal for developers and a fascinating challenge for machines, pushing the boundaries of what they can achieve. Section 6. The significance of the Turing test in AI. The Turing test remains a cornerstone in the field of artificial intelligence, serving as both a benchmark and a philosophical question. It compels us to consider not only what machines can do, but also what they should do. The test has spurred significant advancements in AI, particularly in natural language processing and machine learning. By setting a high bar for machine intelligence, the Turing test has driven AI researchers to develop systems that can understand and process human language with increasing sophistication. This pursuit has led to the creation of AI that can compose music, write poetry, and even mimic human emotions in conversation. Moreover, the Turing test has philosophical implications, prompting discussions about the nature of mind and machine. It challenges us to rethink our definitions of intelligence and consciousness, and to consider the ethical dimensions of creating machines that could one day challenge human intellectual capabilities. Today, the influence of the Turing test extends beyond theoretical discussions and into practical applications in technology. AI systems developed to meet the challenges of the Turing test are now integral to various technologies, from smart assistants in our phones to customer service chatbots and beyond. These AI applications are not just about mimicking human conversation, they are about enhancing human-computer interaction to make it more natural and efficient. The Turing test has guided the development of AI systems that can understand context, make decisions, and even learn from their interactions, making everyday tasks easier and more intuitive. The ongoing advancements in AI prompted by the Turing test are also raising important questions about privacy, security, and the future role of AI in society. As these technologies become more embedded in our lives, the need for clear ethical guidelines and robust security measures becomes increasingly important to address the challenges posed by highly intelligent machines. The Turing test opens up a Pandora's box of ethical considerations, particularly as AI begins to blur the lines between machine and human intelligence. As machines become better at emulating human behavior, the responsibilities of AI developers and users become more complex and significant. Issues such as data privacy, consent in interactions, and the potential for AI to perpetuate biases present real challenges. The development of AI that can pass the Turing test involves not just technical skill, but also a deep understanding of ethical implications. This requires a multidisciplinary approach, combining insights from technology, philosophy, and ethics. Moreover, the possibility of machines that could potentially possess or mimic consciousness raises profound questions about rights and treatment. The debate over whether highly intelligent machines could ever be considered persons under the law is not just speculative fiction, but a serious consideration for the future of AI regulation and rights. Alan Turing's legacy is vast and varied, impacting fields from computer science and artificial intelligence to philosophy and cognitive science. His work laid the groundwork for the digital age, and his ideas continue to fuel innovation and debate. Turing's influence extends beyond his historical contributions. It inspires ongoing research and exploration. In AI, Turing's concepts are continuously explored and expanded upon. Researchers and developers draw on his theories to push the boundaries of what machines can do, aiming to create AI that is not only functional, but also adaptive and insightful. Turing's work also prompts important discussions about the future of human-machine interaction and the ethical dimensions of AI. Turing's contributions go beyond technical achievements. They include a profound philosophical inquiry into the nature of intelligence itself. His legacy is a reminder of the power of interdisciplinary thinking and the importance of considering the broader implications of scientific advancements. Alan Turing's contributions to computer science and artificial intelligence are monumental, shaping the landscape of technology and philosophical thought. The Turing test, while simple in its premise, continues to challenge and inspire, serving as a benchmark for intelligence and a mirror reflecting our own understanding of the mind. Turing's work compels us to look forward, to imagine a future where AI might not only replicate human intelligence, but also offer new ways of thinking and solving problems. As we continue to navigate the complexities of AI and its implications, Turing's legacy offers guidance, caution, and inspiration. Reflecting on Turing's impact, we are reminded of the importance of innovation tempered with ethical consideration. His legacy is not just in the machines we build or the tests we devise, but in the thoughtful consideration of what it means to be intelligent, both for humans and machines. Turing's life and work continue to influence not just technology, but the fundamental questions about our own humanity.